Here we go, kids. Today we're going to talk about geometric sequences. This is part of our series on linear functions. This is geometric sequences. Here's the general equation for a geometric sequence. Pause the video, write this down. A sub n, remember n just means that that's the variable that's used in our equation, stands for the general equation. This is a geometric sequence, so by definition, that means that this sequence will be multiplying by the same number each time. So different from an arithmetic sequence. A sub 1 is still our first term. That subscript tells us what term we're talking about. R is called the constant ratio. That's what's being multiplied between each term. If it's a division problem, remember to use the reciprocal. R is what's multiplied between each term. N is again our variable, and in this case it's n minus 1, and that whole thing is the exponent to the R term, to that constant ratio term. Here's where we're going to use some geometric sequence equations. The first example, again, pause the video, copy these down, and then I'll go through and explain them. In example 1, it says to find the next two terms and the constant ratio. So what we're going to do is we're going to first start dividing. So if you can see, these numbers aren't the same if we're adding or subtracting between them. So in between each of these terms, if you divide these terms, you'll find that it's going down, so the numbers are getting smaller. You could divide by 2.5 each time. If it's a divide by 2.5, like I said earlier, that constant ratio is the number that's multiplied. So if it's a dividing problem, we actually need to use the reciprocal. In this case, R is our constant change, is 1 over 2.5, since it's being divided by 2.5. That equals 0.4. So each of these terms in the sequence is actually multiplied by 0.4. So we're going to extend that pattern and do 192 times 0.4. And that gives us the next two numbers in the sequence, 76.8 and 30.72. Again, I found those by multiplying by that R value. It also said to find the R value. In this case, the constant ratio is 0.4. In example 2, find the first 5 terms of the geometric sequence. So we already know the first term is 1/2. That's given to us. So we're starting with 1/2. We also know that R equals 2. That means each term is found, since this is geometric, it's multiplying, and in this case R equals 2, so we multiply by 2. So 1/2 times 2 is 1. 1 times 2 is 2. 2 times 2 is 4. And 4 times 2 is 8. Those are the first 5 terms in this geometric sequence. Again, they were found by multiplying by 2, since that was the R value. And the A sub 1 told us where to start. In example 3, we have find the indicated term of the geometric sequence. So what that's telling us is, here's our start, 6. R is -2. That means each time it's going to be a times -2. And n equals 5. That means we're looking for the fifth term in this sequence, the fifth term. So we need to keep that 6 multiplying by a -2 each time to find the fifth term. There's 2 ways to do this. The first way is to just list all of those numbers. And for some people, that might be the easiest way. So we start with the 6. We do a times -2. That gives us -12. -12 times -2 gives us +24. We keep going. So we have our first, second, third, fourth. Here's our fifth term in the sequence. That's one way of finding it. Now that won't always work because you might find the 40th term or the 50th term. You don't want to list all 40 numbers out. So depending upon how long of a sequence this is or what term they're looking for, we might want to use a shortcut. The shortcut is by using that equation. So I have the equation up above. I'm just going to rewrite it again. So we've got a sub 1 is our first term in the sequence. In this case, that's our 6. R is -2, so that's our base that's going to get repeated. And the n-1, in this case, we're looking for that fifth term, so n equals 5. So this is going to be the -2 part raised to the 5 minus 1. So we go ahead and start simplifying that. First things first, we need to do that 5 minus 1. Order of operations, we need to do exponents first. A -2 times -2 times -2, we repeat that multiplication 4 times out. We end up with a +16. Six times 16 gives us that 96 for an answer. So we've solved it using 2 different methods. Using the long way where you list all the numbers out and using the shortcut, using that equation. If you need to ask your teacher for any questions or have any clarifications, make sure that you are asking questions if you're not understanding. Thanks. Have a great night.